maybe the single most frequent question that we get asked when it comes to vellum is, how do I fill a shape with balloons? So let's just quickly talk through this. We'll just start out with the collider. In our case, let's just use a font for now, dive in there. And what I want to select here is a bold font. I'm going to use the Open Sans Extra Bold here and just go for a single N for Entagma maybe. Next, let's extrude this using the poly extrude. Make sure we check output back here and just dial a distance of 0.2 in here, like this. So that's going to be our collider, which we'll fill. I like to use the same shape to scatter some initial points into this N shape here, where we'll instance spheres onto, which we'll then use as balloons. So let's just copy this here. And to fill the interior of that extra bold N, I want to select a thinner font so we don't interfere with the surface of my geometry here. So let's just go with the Open Sans regular here. Let's dial back the overall font size to say 0.95. Also, let's dial back the extrusion to 0.1 and maybe move our font a tiny bit like this so we're not intersecting the geometry. Get now a smaller N inside of our bigger N, like this. Next, let's quickly turn this into a volume using the ISO offset, set the uniform sampling divisions to 100 so we get a bit of detail in here, and then drop down a scatter to scatter points into this volume. Just set the total count to 20 for now. So we have now 20 points scattered into this volume like this. Next, let's drop down a sphere, which we're going to use as a balloon, set the primitive type to polygon, and give it 16 subdivisions like that, and then scale it down really small, so 0.02 in our case, and then use a copy to points to copy this sphere onto my scattered points, like this. Initial spheres. Let's just check if they're intersecting, and they're not, and they are inside the N, so that's working. Let's rearrange this a bit, and now start configuring our vellum. So as these spheres should behave like balloons, let's just use a vellum configure balloon here, drop that down, and this creates two nodes. We will wire in our balloon geo on the one side and our collider on the other, like this. Finally, let's drop down a vellum solver to solve this later. And now let's dial in the settings a bit here, because with standard settings, this setup will fail. Let's start with the solver down here. What I want to do in the forces, I want to get rid of my gravity. And then in the solver tab, I want to increase my substeps to 8 while lowering my constraint iterations to give a more precise and stable solve. Next, in my vellum cloth up here. Now that my sphere here is pretty small, let's just highlight it, zoom in. Now all these points have a very small distance apart from each other. And in order to accommodate for that, what we need to do is dial down the thickness in the vellum cloth. Otherwise, this will intersect and will try to detangle itself and not work. So let's set this to 0.0005, really small value. And also what I could do to my sphere is now it's got this really regular pattern, which could result in some artifacts in the simulation. So I might be tempted to drop down a remesh down here, wire this in here, and set this to a small target edge length as well, and let this run 8 iterations. So we get a smooth surface which has a bit more irregular shape to it, so we're not getting aliasing in the simulation. Okay, back to my cloth, set the thickness really low. Let's just scroll down here. So I just want to lower my stretch stiffness so that the surface of this balloon can stretch, and leave the rest as is for now. Next, in my pressure constraint down here, let's increase its stiffness so it can push out this stretchy cloth to maybe 6 million, like this. And also check output group and call this maybe P-stretch for pressure stretch. Everything else is fine as is. Let's zoom out a bit here, disable that grid, and now dive into the vellum solver. So what I want to do is I want to basically inflate my balloon. And inflation means increasing a balloon's pressure. So what I need to do is scale up the pressure constraint that we just created with the group P-stretch. That's all of my pressure constraints in there. So let's use a constraint property, which we're going to wire in the force output, and make sure we check group. And we just want to deal with the P-stretch group, that's the pressure stretch. Check this, and now let's animate the rest length scale here, which will just scale up the pressure value. So let's animate it from 1 on frame 1, then skip to frame 96, and let's maybe try a value of 80 there. Keyframe this, and go back to frame 1. Let's head back up, highlight the solver. Again, save this, keep our fingers crossed, and run the simulation. So what we're seeing here is this simulation runs decently. We're getting a bit of coarse areas here, maybe where we have many intersections, many of those balloons pushing together. So either what we could do is make sure that our initial points, our initial balloon positions are a bit more homogeneous, so a bit more uniformly scattered. And also what we could try is increase the substeps in our vellum solver here, if we are seeing some errors here, which we are currently not. So, pretty straightforward setup. Only thing to keep in mind is to basically dial in those settings. One of the major components here was the thickness, which irritated me a lot when I first set this up. So the thickness has to accommodate for the initial sphere size here, in order for those points not to be detangled first. And then basically outputting this p-stretch group, so we can isolate only the pressure constraint and later animate it in the vellum solver using the vellum constraint property. So yeah, that is inflating a bunch of balloons inside of a shape.